Okay. Hi, so I'm a PhD student also at the Modernising Medical Microbiology group here in Oxford, and I'm going to zoom out a little bit compared to the talks that we've heard and talk to you about my systematic review on the epidemiological, microbiological and genomic risk factors for plasmid-mediated hospital outbreaks of Carbapenemase-producing Enterobacterales, or CPE for short. And we care about this group of pathogens because, as we've heard from Lisa and Ben, they've been highlighted as one of the critical priority pathogen groups by the WHO because they mostly cause severe and difficult to treat infections in critical care settings, and also because the mechanism of resistance, this beta-lactam hydrolyzing carbapenemase gene, is often carried on plasmids, so they can spread quite widely by horizontal transfer between both commensal and pathogenic bacteria. So why do we need a systematic review on this subject? Well, imagine that you're the head of an IPC, an infection prevention control team, at an NHS trust, and you're notified of 2 outbreaks. In the first outbreak, you have 2 neonatal patients with really severe bloodstream infections that aren't responding to any of your usual treatments in a small hospital. Your blood cultures show that there are 2 different bacterial species responsible, but on whole genome sequencing, it's revealed that they both carry the same carbapenemase gene downstream of the same transposon TN125. In your other outbreak, you've detected 5 cases already of intestinal colonization in elderly patients through your screening program, this time in a general medical ward in the most busy hospital you have in the trust. No infections yet, but all of the isolates belong to the same high-risk clone of Klebsiella pneumonia that's caused massive outbreaks elsewhere in the world. And indeed, on whole genome sequencing, you find they all carry the same epidemic plasmid with the same carbapenemase gene. So in this situation where you might have limited resources to tackle these outbreaks, how do you decide which presents the bigger risk to public health? If something is clear, it's that this is not an easy decision, because currently we do not have a framework that helps us quantify how much these various outbreak features contribute to making an outbreak bad. But what outbreak features are we talking about here exactly? Well, these broadly fall into 3 groups. Your epidemiological features, so this includes things like the type and the capacity of the hospitals and the wards involved, and how the beds are organised into either private or shared rooms. Your patient characteristics, age, sex, comorbidities, as well as the availability of toilets, sinks, showers. Second, your microbiological features, so the number and type of bacterial species and sequence types involved, as well as any other resistance and virulence phenotypes they carry. And third, the genomic context of your carbapenemase genes. So not just the types of plasmids they're carried on and how easily these spread horizontally, but also the smaller mobile genetic elements that they are surrounded by, like transposons, insertion sequences, that might play a role in between plasmid transfer and also chromosomal integration, as well as other resistance and virulence genes that co-localize on these plasmids. So in my project, we've set out to do 3 things. First, identify potential risk factors for hospital CPE outbreak dissemination, then to quantify the risk associated with these factors, and use this to develop a risk score. So to address aim number 1, we're undertaking this systematic review of publicly available outbreak reports. And after screening through 6 databases, as well as outbreak surveillance reports and conference abstracts, we've identified over 3,000 non-duplicate records. But luckily, we do have a very handy review management software to manage all of these records. And while screening through all of these is still a work in progress, we estimate to have over 200 records to analyze. So the next challenge from this is to extract data from these very heterogeneous records, which all use slightly different definitions of cases and also report genomic analyses in different ways. So to give you a flavour of this histogram here on the right shows the outbreak size distribution of the first 60 eligible records. So these range all the way from just 2 case clusters to over 200 and involve a number of different genes and often even multiple. Once we have this data set, we're going to use this to build multivariate regressions for outbreak size and other markers of how bad an outbreak is, and then feed the correlation coefficients into a risk score, which will hopefully be a useful tool for decision making in future outbreak scenarios. So I'd like to thank all of these people and my lovely audience for your attention. If you have any questions, I'll be happy to answer them on the online form.